All right, so in this session, I'm just going to cover off a few findings relating to SQS, so simple queue service, when it's connected to Lambda functions, and when you're using event source mapping to trigger Lambda functions from your SQS messages. So this actually came about because we've got our offers repository or our offers management solution, which uses SQS to basically stage messages. And we put all of our messages into a queue, kind of like a little bucket. And then Lambda functions pull those messages out from the queue and then process those messages and dump them into DynamoDB. So it's very much like this kind of diagram. So you've got your arriving messages. So before here, we have a S3 bucket, which we are using either Redshift or SAS to generate a CSV file of some sort. We dump the file into the S3 bucket. Then we have another Lambda function that pulls that file out of the S3 bucket and then splits a massive batch file into hundreds or thousands of individual SQS messages. So all these little gray boxes. So each of these gray boxes in our solution represent a marketing offer that we've designed for a customer. And then we have each of these messages, and then we want to send them into DynamoDB over on the right. So what we do is we use Lambda functions to pull the message out, format the message appropriately, and then write them to DynamoDB. So we've got messages coming in, SQS queue here, Lambda functions. So a few things to note. You can see that you've got 6 little blocks here that get passed in and 6 little blocks that get passed out. So what happens is messages aren't actually pushed into Lambda functions in this instance or in this design. Lambda functions actually do a long poll, as in they call the SQS service for any available messages on the queue, and then they try to, I guess, fill up their little batch. So in this instance, they've got a little batch of 6. So when you're using event source mapping, which is this kind of pattern that we have here, which links a SQS queue directly to a Lambda function. So the availability of a message in the SQS queue will trigger a Lambda function to start to poll or start to call for messages in the queue. In this example, the micro batch is set to 6. There's a maximum of 8 messages that can be pulled from the queue into the Lambda function for processing to be written to DynamoDB. So in this example also, you can see that we've got 5 Lambda functions running concurrently. So yes, you can, because Lambda functions are serverless, you can scale out depending on how many messages are coming through. So if more messages are coming through, then Lambda can scale up to handle and process more messages in parallel. So this is all using a standard SQS queue. There is FIFO queues, so that's first in, first out, and that ensures that messages are processed in order. But we're not talking about FIFO queues today. We're using standard queues. So as messages pile in, we will just end up spinning up more Lambda functions and processing more messages, depending on the load. Now, the issue that we ran into was Lambda functions has a concurrency limit. So here we've only got 5 Lambda functions that are spun up to process the messages, but on each account, there's actually a soft limit. On production, I believe it was set to 300. Not sure why it's set to 300 on the production account, but 1,000 is the standard for AWS accounts these days. And I'm just looking at the development, the discovery analytics account, and that's set to 1,000 at the moment. So Lambda functions will spin up to that amount. And then once it starts hitting that amount, like if it's asking for 1001 Lambda functions, then it will just throttle and no longer spin up. All right, so there was that problem. So when it hits the limit of 1,000, then any other Lambda functions or any other functions that need an instance to be called, it just won't run. It'll just get throttled. So when you go over to functions here, you can see that we've got many functions running. So all of these functions are kind of sitting there idle generally until they've got a request coming in for one of these functions to be spun up. And so what happens is this is kind of reflective of what production would look like, in that analytics does have a number of functions in Lambda, but also there are other Lambda functions also on the same AWS account. So when our process, our office management process, which was going through the process of generating a CSV, splitting it into thousands of individual messages, processing all those thousands of messages on Lambdas, and then Lambdas was spinning up multiple instances of Lambda functions to handle the load, and then we ended up hitting the limit of 300. So this actually came about because the amount of time that it takes to run our Lambda functions was taking 15 minutes per run. And this was all because of the URL shortener, which was basically timing out. And we had Lambda functions just sitting there waiting for the short URL to come back, and which it didn't. And we ended up having Lambda functions sitting there for 15 minutes timing out. And so we actually extended that from 30 seconds as a Lambda function timeout to 15 minutes. And that's what caused the issue. So in all of that, I've gone through and started to revisit all of the settings that we had applied to this solution. When I look through the settings that were applied already previously for production, I don't think much thought was put to it just yet. All right, so we've got all the messages in the queue, a whole bunch of Lambda functions processing batches, and DynamoDB table. Okay, so the initial thought on how to address this was, let's use reserved concurrency. So you can see here that full account concurrency is 1,000 Lambda functions. Then you have this unreserved account concurrency. So that means that any of the 1,000 concurrency, I guess, capacity that hasn't already been reserved for another function, this is the remaining for all the other functions to use. So let's go back to here. Let's say this first function, I have reserved 10 units of capacity for this function. That means any other function that has no reserved capacity allocated has access to the 990. But the 10 units that I've allocated to this first function, this function is allowed to use those 10 units of capacity, it can't use 11 units of capacity. But also means that all these other functions down here are not allowed to touch the 10 units of capacity that was allocated to here, to this first function. So it's kind of like just grouping the account concurrency capacity. So it's just ensuring that some functions are always allocated a set number of concurrency capacity, and that other functions are not allowed to touch it, but also limits the amount of account concurrency capacity that a single function has access to. So going back to our situation where we had thousands of messages dump into the SQS queue, we had a lot of Lambda functions spin up, Lambda function instances spin up to process all those messages to dump it into DynamoDB. But because we had extended our Lambda function runtime, our maximum runtime to 15 minutes, we ended up having a lot of Lambda functions just waiting for the URL shortener to respond back with a shortened URL. So we're going to propose that we limit the amount of Lambda functions scaling up to 10. So that would be our first use case. All right, so if we limit it to 10, that means we end up with a setup similar to this, where we have 1,000 for the full account, but we have 990 unreserved, and then 10 allocated to a specific function. So that way, there's less chance of that single function resulting in basically a blockage and limiting access for all the other functions. The other thing is we can control the way that the polling is managed. So you see here that we've got 6 messages that have been micro-batched. Now we can micro-batch up to 10. But also you can set the way in which the micro-batch is populated, right? So let's say you've got messages coming in. So you've got one message coming into the queue every 5 seconds. Now, if you were to micro-batch that up, where do you draw the line for, I guess, filling up this micro-batch and processing it? So let's say this Lambda function will call SQS and pull messages over. But let's say there's only one message in there, and then that message is now put onto the micro-batch. But it's still got a capacity of 5 additional messages. So how does it know to, I guess, wait for the additional 5 messages to be available to put into the micro-batch before processing? So that is what is known as the batch window. So we're looking at the code over here. So the maximum batching window in seconds. So at the moment, I've set it to 30 seconds. So that means if you think of, there's a process along here that will try to fill up that micro batch. So what it does is you've got a little process over here that will call SQS, pull in messages, and it will fill it up to 6 messages. But also, when it calls for messages, it's going to do a long poll. So a long poll is a request into SQS, but it'll actually maintain that connection for a set amount of time. So what I've set it to is 30. So this service over here will call SQS and will maintain that connection open for 30 seconds. So any new messages that come within the 30 seconds will be put onto that little micro batch. So if, let's say, if we've got messages coming in every 5 seconds and we've got a long poll of 30 seconds, then there's a chance that we'll end up populating the full 6 messages into this micro batch. And then once that's populated, it'll get passed on into Lambda for processing. Now, let's say if it was coming in at a message a second. So then what happens is this process will do a long poll for 30 seconds. Messages will come in. So 6 messages would come into the queue, get passed on to the, I guess, event source mapping resource, and then would fill up the 6 messages within 6 seconds, right? So even though it's polling for 30 seconds, it's already completed a micro batch of 6 messages within 6 seconds. So once it's completed that, then it would pass it on to the Lambda function and start the process. So it won't actually wait until the end of the 30 seconds. It's filled. So then let's continue with the processing. All right, so the batch size of 6 is actually defined in the batch size. I've actually just set it to 5 in this instance. So I've set my batch size to 5, the window, the maximum polling message on the queue to 30 seconds. And I've also limited the amount of Lambda functions that can be spun up to 10. The way that I've set that is we've got that here against the insert offer orchestration function, which is AWS Lambda function. And that's just set the reserved concurrent executions of 10. So that means on this diagram, I've got 5 Lambda functions. I'm just saying this function can only spin up 10 maximum. All right, coming back to here. So we've got our messages coming in. We've got our event source mapping resource about this area that populates the micro batches. The micro batches are polling SQS. They're long polling for 30 seconds. They're filling up their little batch sizes according to my settings to 5 when 5 messages are filled, or if the long poll has completed, as in hit a maximum of 30 seconds. So let's say it's polling, 4 messages have come in, you've got 4 messages on the micro batch, then it's already reached the 30-second timeout window, then those 4 messages will get sent into Lambda function for processing. Lambda function will process the messages and then insert those 4 messages into DynamoDB. And then that completes the, I guess, workflow or workload. Okay, here's where we can probably diagram it out a little bit nicer, make it a little bit bigger. So we've got an application, right? We have, before this, we had our CSV. Then we've got our application. So we've got a Lambda function that picks up that CSV, and then we put a message onto the SQS queue, which is this section over here. So we've got a message, we put that onto the queue. Then we've got, so this is kind of just breaking down what happens at an individual message layer. So as I said, we micro batch the messages, but ignoring all the batches and everything, we've just got a message that gets passed into the Lambda function. what's this? Lambda service. Okay, so this is actually, think of this as this bit in between, the bit where it queues all the messages. Okay, so you've got the Lambda service, it's queuing the messages here, then it invokes the Lambda function. The Lambda function processes the messages and sends back a success. So success as in no failure. And then what happens is the middle layer will delete the message. So it receives a message, sends the message into Lambda function. When it's a success, then it will delete the message off the queue. All right, so the thing that I wanted to explain is this bit, when you receive a message and when you delete a message. So when you receive a message, see we're looking at SQS at the moment, Amazon SQS, we're looking at the queues. Let's just take this first example. We've got a RSAQ build queue. So what will happen is you'll have your messages piling up on messages available. Then what happens is Lambda function will end up polling that queue. So SQS it has a connection to Lambda functions through the event source mapping. And when there's a message on the queue, then SQS will tell Lambda service, hey, you can do your polling against the queue to retrieve any messages. So it will poll the messages back over here. It'll start polling and populating the microbatch. When it starts to populate the microbatch, what happens is the messages will start to get flagged as messages in flight. So they're not necessarily available anymore, but they're in flight, as in they're being processed at the moment. So while the messages are in the microbatch, they're in flight. And also while they're getting written to DynamoDB, they're still in flight. So going back to this example, they receive the message, and it's at this point when it receives the message, when it gets sent to the Lambda service or the Lambda function, this area on the right, the message on the queue still exists, but it's simply got a new flag that it's saying that it's in flight. So it's not actually retrievable by any other, I guess, service that might call the queue. And it's at the very end, when it returns a success, then this Lambda service will delete the message that's in flight on the queue. Alternatively, if Lambda function was to fail on step 4 here, then step 5 would be to release the message. So it wouldn't actually delete the message because the message failed, but it would release all the messages that was in that microbatch. All right, that's when we want to start talking about retry. So you send a message through, it gets queued up, Lambda function starts to process it. If it fails, then you're not deleting your message, and then you're putting the message back onto the queue or making the message available. So it's going from an in-flight status back to a messages available status. So you might have your one message here, then it's picked up, then it's the one message in flight. The Lambda function failed to process that single message, and then the single message would have its status updated back to messages available. and then another subsequent Lambda function can go in and pick it up and try again. Okay, so that whole idea of retry, it's defined in this area here. Okay, so it's defined in here. So I've got it to 6. So 6 means it will actually go through this whole process of receiving the message, invoke the function, try the function. If it fails, it will release the message and try again. It will try that 6 times to make sure that it's going to run successfully. I'll cover off why this was set to 6 in a moment. Then we've also got visibility timeout. Okay, so going back to here. Let's say you've got your messages come in, message gets sent to Lambda service, that starts to invoke a Lambda function, and for some reason, the Lambda function takes 15 minutes to run and never comes back. So the visibility timeout is actually the timeout in which the message is actually set to a in-flight status. So remember, you've got your message coming in, so it's available. Then it gets sent to Lambda function. Then it's in flight. If it fails, it goes back to available. But there's also this setting called visibility timeout. So visibility timeout means it's set to 390 at the moment. So 390 seconds. If 390 seconds pass, then it gets sent back to available. Okay, so just to repeat, so you've got one message come in, Lambda function gets sent to the Lambda function for processing. Let's just say that the Lambda function was running for 15 minutes. But how it's set up at the moment is if after 390 seconds of the message being in flight status and it hasn't received a success or failure, then it will revert back to available and it's available for another function to pick up. So it's just a kind of a failover kind of thing. All right, so okay, so visibility timeout. Okay, so okay, so this one I'm going to have to explain without a diagram. Let's just say hypothetically we've set our maximum concurrency limit to 3. Okay, so remember in my code I've actually got it set to 10. So 10 was with relation to this figure, the Lambda function concurrency, and I've set it to 10. So I've reserved 10 concurrency, as in reserved concurrency capacity for one specific Lambda function to 10, and then the remaining 990 is available for all the other functions. But just for explanation purposes, let's just assume that it's set to 3. So I've set it to 3, and that means I've got a maximum of 3 Lambda functions available to run to process our records. This stage, as in the Lambda function stage, is separate to the Lambda service or the event source mapping area over here in the middle, the area which is populating the micro batches. So the micro batches scales differently to the way that Lambda function scales. So I might have 3 Lambda functions as the maximum reserved capacity, but the event source mapping polling, the thing that is long polling the SQS queue, trying to populate the micro batches, it might be queuing up 5 sets of micro batches for me. And so the first 3, it would populate these queues or these micro batches, send them into Lambda functions, and then they get processed correctly. But these last 2, they might start to get set up in their micro batches. Then they get sent into Lambda, but because I've got a maximum of 3 Lambda functions as the maximum concurrency, these would actually end up failing. Well, actually, they end up not doing anything. So the micro batch goes into the Lambda service saying, hey, I've got a batch of 6 messages. They need to be processed by a Lambda function. Give me a Lambda function. The Lambda service will just simply not respond and not do anything. And it will just end up waiting there and not doing anything. So this is kind of the reason why you've got the visibility timeout to account for this instance where you've got your 3 reserved capacity and that process is fine, but then you've got your additional 2 here that have been set up. You've got 2 little micro batches. They're getting sent into Lambda service, but the service is actually not responding because it's already hit the maximum of 3. And then you'll just end up having your little micro batch sitting there, not doing anything. And that's why you've got your visibility timeout, which I said will end up moving your messages from in-flight status back to available after 390 seconds. So the reason why it's set to 390 seconds, I believe the Lambda function, so at the moment, the Lambda function is set to maximum of 60 seconds before it times out. I've got a batch size of 5. So that means I've got 5 messages coming in. They've got 60 seconds to process all the 5 messages before timeout. So hopefully it finishes within about 30 seconds or so. And then it'll send the messages to DynamoDB and then also delete the messages off SQS. Now, under the advice of AWS, they say that you should set the visibility timeout to, I believe, 6 times. Yes, okay. So I believe they advised to set it to 6 times the Lambda function timeout. So I've got a Lambda function timeout of 60 seconds. 6 times means I've got 360. But then they also say to also add the maximum batching window. So that's 30. So I've got 360 plus 30 is 390. So that's what I've set as the visibility timeout. So that's just to ensure that this whole process has enough time to go through and process all these records. So as I said, if you've got all your messages piling up here, you've got messages being micro-batched, then you get them passed into Lambda functions. We've got a maximum concurrency of 3, just hypothetically. Then we've got these micro-batches down here, which is 2 sets. They're going to end up hitting the visibility timeout of 390. And then they're going to be getting passed back into the SQS and being available for another set to pick them up. So then you're hoping that they get picked up by one of these first 3 to be processed. Now, here's where we go into the dead letter queue and the retry. Now we're going to get to the 6. So it's going to go through this process multiple times, right? So let's say we've got a message comes into here, gets put onto this fourth micro batch. Obviously, this won't get processed, gets put back. Then let's say it happens to get put back onto the fourth again. So it can do this up to 6 times. It can retry this message. So this process, it can go through 6 times. And then after 6 times, it will end up hitting the dead letter queue. So it will retry to process. And if it happens to end up on one of these little micro batches 6 times, then it'll fail back and then end up putting it on a dead letter queue. So you've got SQS queue here. There could be another queue elsewhere, which is actually not hooked up to anything. And this is just indicating that, hey, I've tried this message multiple times. It's not processing successfully through the normal processing approaches that we've defined. And hey, can you look at this message? Maybe there's something wrong with this message. I don't want to try this anymore. But anyway, so that's why it's set to 6, saying that for each individual message, you can try it up to 6 times. If it's got to the 7th time, it's going to end up on the dead letter queue. So that's this setting, dead letter target ARN. And so this is another queue, which I believe is up here. And this one has no settings attached to it. And this actually wouldn't be attached to anything at the moment. It's just like another bucket just to store all of the problematic messages. All right. So that is pretty much all the concepts and ideas. So we had SQS messages. Okay, let's go back to the beginning. We had a CSV that gets written down, and this is for batch processing. So each day we've got messages that get dumped into SQS that were sourced from CSV files. And there could be thousands or tens of thousands of these messages getting dumped into SQS. Then we were forming little micro batches. And then these micro batches can be anywhere from 1 message to 10 messages in a micro batch. And then they get sent into Lambda functions. And then these messages get, formatted and then dumped into DynamoDB. And the problem that we had was we had too many messages coming in, but then when we were processing them, because we were also making an API call to the URL shortener, and the URL shortener was taking a very long time to run. So normally it was originally designed to only take like less than 1 second, but in production, it was actually timing out, and we were waiting there for 15 minutes for a response. No response was coming back, and these were actually timing out. But because we had Lambda functions sitting there running for 15 minutes or waiting for a response, we also had more messages piling in that resulted in more Lambda functions spawning, and we ended up hitting the maximum concurrency limit. So Lambda concurrency limit on our production account, which was set to 300. So we had our single Lambda function consume the full capacity of the account, and then that in turn was blocking other Lambda functions from spinning up and processing their requests. So to address that, we're suggesting that we used a concurrency limit of 10, so a reserved concurrency limit of 10. So this is different from provisioned concurrency. So this is reserved concurrency. And now because we've got 10 reserved concurrency, then we have to consider the out of sync scaling between Lambda function concurrency and the event sourcing concurrency. So the way that it forms the micro batches is independent of the way that Lambda functions are scaled. So to address the instance where we've got micro batches getting formed, but we've got no Lambda function capacity, then that's where we start to uh, tinker with the visibility timeout and the maximum attempts, maximum retry attempts. Yeah, that was pretty much it. So just to go back, some of the settings that we did have previously in our production, we didn't have visibility timeout set. We didn't have maximum receive, or we actually had a maximum receive count of, I think it was 0. So each message would get attempted once, and if it failed, it would never get retried. Then we had maximum batching window set to 0, I believe, as in we didn't have this value set at all, so it was using the default. Then the maximum batch size was, I don't actually remember what it was set to. It might have been 10 or might have been 0. It might have been just the default too. I got a feeling that both these settings weren't actually set. So hopefully with some of these settings set, now we manage the flow in which Lambda functions are spawned, and also we manage the way that the micro batches are created, and we also manage the way that we look after retries. So if we've got these micro batches not being processed by Lambda functions, so they get dumped back into the queue and getting set to available so they can get picked up by another micro batch process. And we've set the visibility timeout for this instance. And what else? I think that was about it. Yeah, so there was other alternatives to address this solution. So we could have looked at setting the SQS queue as FIFO instead of standard. But the reason why I didn't look into this was that would have resulted in a full stack rebuild, meaning I'd need to pull down the whole stack. I need to redeploy it in production. That would result in a new API endpoint. And then other consuming applications would need to update their configuration settings also. But for now, I think I'd leave that. FIFO queues are a whole another beast, and you have to have all of these other settings to handle all of their special features also. But again, I think this is going to be good enough, and that kind of explains how this solution was resolved. All right, thanks.